Hello, this is Operation Valkyrie. Let's meet the team. We have our computer science major, Andrew Nguyen, and our 3 computer engineers, Renzo Aravallo, Servando Olvera Trejo, and I, Andrew Espinoza. For our senior design project, we've been working on a wasp elimination drone. Wasp nests are often found in hard to reach places like roof corners or high up in trees, and can be rather annoying or pose a serious threat to those who are allergic. Traditional methods like climbing ladders or using chemicals can be dangerous, inefficient, or harmful when dealing with wasps. Our project aims to tackle this problem with a drone capable of getting close enough to a wasp nest and neutralizing it with a targeted spray of soap water. The approach we decided to take involves a custom drone equipped with an FPV camera, a companion computer, and a water cannon, which is composed of a gimbal, pump, and water tank. The drone is piloted manually via a transmitter and a headset. When a wasp nest is spotted, the drone can enter target mode via the flick of a switch, where the gimbal is used to aim and fire soap water at the nest, all while the drone remains in stable flight. Here's a quick look at one of our first test flights, as we were still getting used to the drone. As you can see, we had not yet discovered GPS flight. However, that will come soon. Let's talk about the system architecture some more. At the core of the drone, we have the Cube Orange flight controller, which is responsible for handling all flight stabilization and communication with the transmitter. A Raspberry Pi 4B acts as the companion computer and runs a custom Python script which uses PyMavLink to communicate with the Cube Orange. The Pi constantly listens to the commands being sent by the transmitter and uses them to control the position of the gimbal and trigger the pump located in the tank to fire the water. The FPV camera is mounted at the front of the drone, right above the gimbal to aid in both navigation and aiming. Let's dive deeper into the operation of the drone and control flow. When approaching a wasp nest, the operator will flip a switch to enter targeting mode, which will disable pitch and yaw control. However, altitude and roll control will still be available so that the operator can do slight adjustments mid-air if needed. But once in targeting mode, the Raspberry Pi will intercept the transmitter input values sent to the Cube Orange and repurpose them to aim the gimbal and trigger the water cannon. The water cannon uses a small but mighty water pump to shoot a stream of soap water at either full power or medium power. This is an effective way of taking down wasps and damaging their nests without harming the environment. Now let's see some flight footage of the drone using GPS to demonstrate its hovering capabilities. One of the main challenges we've encountered in this project has been implementing the logic to disable pitch and yaw control. While we have a clear approach to implementing this, the software has been difficult to work with, and progress has been slowed. Another significant challenge was tuning the gimbal for precise aiming. Initially, we experienced a lot of jitter with the servo motors, which made aiming rather unreliable. We solved this issue by switching from software-based PWM to hardware PWM, which greatly improved the precision of the gimbal. At this stage, we are still in the works of fully implementing the flight mode switching logic due to the aforementioned hurdles. Additionally, the integration of the water tank is still in the works, but nearly there. This has been our wasp elimination drone project, and I hope you found it interesting. Thanks for watching.